Good morning. Well, they asked me actually to put on my EFF hat where we're civil rights advocates and give one of my very scary talks about how AIs are going to take away all our privacy and freedom and stuff like that. But I said I want to do a much more upbeat talk about one of the technologies I'm really excited about, robot transportation. That's automatic cars, self-driving cars that can move you around and use a medium level of AI. Not the level of AI that some of the people here have been talking about, a human level intelligence, something much less, and thus something I hope that we can see in a shorter time frame. I'm in fact going to identify why I think this is probably the biggest project that computer people can do now for immediate benefit for the world. First I want to give you some numbers though about the problem that robot cars will solve. Human drivers really suck. I know, because they kill 40,000 people in the United States every year. Around 1 million people worldwide are killed by human drivers. Now, that's the largest cause of death between the time you stop dying of childhood diseases and the time that old age gets you, until Greg Benford solves that for us, or Aubrey de Grey is going to solve it for us later on as well this afternoon. So, in fact, once Aubrey and Greg solve this problem for us, we're really going to need to stop dying in car accidents, because that's going to be the thing you're going to be most afraid of. There are 6 million accidents in the United States every year. 1.8 million of them cause injuries. The National Highway Transportation Safety Agency has suggested that costs $230 billion per year. That's about 2.5% of the United States GDP. That's no small thing. Worked out per mile, it's 8 cents a mile, which used to be more than gasoline. Gasoline has gone up a little bit. We spend about 50 billion hours a year in the United States driving, and that's 8% of the GDP if you account for the value of the time. 40% of the fatalities that we get from driving come from things like drinking, which hopefully the robots won't do. 80% of accidents have been shown to have been caused by inattention, driver inattention. People texting on their cell phone is the latest hot button as far as that's concerned. Every person loses 41 hours a year of their life. Sorry, not people in New York. They at least double that. To congestion. For every car in the United States, there are 3 parking spaces. In fact, one estimate said that in Los Angeles, which is admittedly the worst case example of this, 60% of the real estate was devoted to cars. Roads, highways, parkways, all this, driveways, garages, all that stuff. As well, cars take up 25% of our energy budget and produce about a similar amount of our CO2 in our greenhouse gas problem. So energy and transportation turn out to be the 2 biggest industries in the world. This is major, major stuff. We're going to talk about bringing, and I'll do a special slide on this, but bringing Moore's Law, which we just saw lots of great slides on the way, to transportation. As I walked here from the hotel, underneath us, they were building 19th century transportation technology, a subway. That's what governments build today in technology. They're still in the 19th century. So, maybe a lot of you have seen this, but the thing that's getting people excited is that this has become no longer a science fiction movie technology, but something that's actually real. The military started contests for people to build self-driving cars. That resulted in what I like to call real garage innovation. And it was much easier than some people expected to be. It's not here today, you can't buy it today, but this is not artificial general intelligence. I sometimes call this artificial horse intelligence. Actually, Volkswagen has a project where they're trying to see if they can learn how locusts are able to just swarm around and not hit each other and move in streams and so on. So maybe it's just artificial locust intelligence. This is a slightly lower level than some of the papers you've seen presented today. I'm going to show you some videos. This is from a NOVA program. I guess we're not getting the audio on this, but John Lithgow is just telling you about how the robot car is driving in the desert race, the second one, and that the humans are having trouble keeping up with it. The next one, we will need audio for the third one, by the way, so if you guys want to work on that while I move to the second one. These are some shots from the second DARPA Grand Challenge, which was a desert contest that was successful. The first one was a total failure. 2 years later, they had a big success. And you can see the vehicles able to basically manipulate a desert. These are, dirt roads, fire roads in the desert, going down windy paths, analyzing, learning where road is, and so on. A simple problem compared to the problem of driving on ordinary streets, but nonetheless something they were able to achieve. I will skip out from this. Do you think we have the audio yet? It's in. It is. Okay, great. So we'll go. This is a little piece that Wired did about the third challenge, which was to drive in city streets.
This is Boss, the car that won the DARPA Challenge of 2007 for self-driving vehicles.
The vehicle uses GPS and lasers and radar to kind of figure out where it is in the world and look out and see where the other cars are and how to drive safely around them. The big silver box over here is the car's brain, and it's a compact PCI chassis. Each of these is a Core 2 Duo, so there's about 10 of them in here, and they're running Ubuntu 606 Linux. Up here we have our hard drives where we can store all the telemetry, everything Boss saw and thought. So if it makes a mistake, we can go back and look at why that happened, and it's about 1 terabyte of storage there. We have a monitor and keyboard so we can debug things. On the left here we have our GPS and a planning system which uses GPS data and an inertial measurement to figure out where the vehicle is. Some safety hardware, flux capacitor, and power system.
GPS is fairly, it's not down to the centimeter really. How does it avoid running over like my dog, say?
Well, so the GPS wouldn't tell you where your dog is, so it uses the lasers to look out and see where your dog is and tries to avoid it. And then we use lasers on the back of the vehicle to look down and see where the lane markings are. So as it's driving along, it can detect those and kind of center itself or register itself to the road.
So how long was this in development? This is a very complicated endeavor, I'd imagine.
The actual Urban Challenge, this vehicle, we started working on about 1.5 years ago. So we had about a year and a little bit before the race. So the challenge was a 60-mile race in a suburban environment. The vehicle had to be able to drive among other traffic. So on challenge day, there was 10 other vehicles out there with it and 50 human-driven vehicles. It had to stop at stop signs. It had to yield for traffic. It had to be able to park. And it had to be able to do it all completely autonomously. That means without remote control, without somebody in it, making all its own decisions.
So how long until I can just kick back on the highway and let my own version of Boss just do the driving? What do you think? 10 years, 20 years? How far away is that?
We think kind of from a technological point of view, it's about a decade out. So maybe by 2020, you'll be able to buy a car that has these features, maybe a subset of what Boss can do, right, and get you between one place and another without you having to worry about it.
So to think about that, a team at a university in 18 months developed a prototype vehicle that could actually work, drive around city streets. The rules of that contest were follow the California Vehicle Code, by and large, something that humans actually are not able to do. This is just some of DARPA's video of the vehicles going on. I don't know why it won't expand out, but you can see them stopping at lines, reading stop signs, following roads, going to four-way stops, manipulating and stuff like that. Not all the cars completed successfully, but 6 did. So some of this technology is actually also coming to you in cars already. This is a list. I won't go through everything on it, but these are some things you can buy in cars today. A car that can do parallel parking on itself, cars that can space themselves from other cars, cars that will see if an accident is coming and prepare the airbags, cars that will notice if you're trying to change lanes into another car and will actually squeeze one of the brakes to veer you back, or in some cases, they'll actually manipulate the steering. There's a car that reads the street signs that you can get from Audi, I think. No, it's Opel, that will tell you what the most recent speed limit sign you are. A lot of this technology is coming, and it's going to be sold this way. It's going to be sold in high-end cars to people who want to buy a safer car so that their kids will not smash the car nearly as often. That's a good market that you can sell things to. And we will make safer and safer cars until these technologies become more widely deployed. But the barriers to making this happen are, I think, unfortunately, more political than they are technological. I'm not saying this is a solved engineering problem, but of all the problems I've seen at this conference, this is the one I most believe you could say pour money on it and we'll have a solution. There's science to be done, but this is much more in the pour money on it, and there's a class. So the huge positives we get of this are not just the lives I talked about, the hundreds of thousands of lives of people killed every year, but I believe potentially the elimination of the importation of foreign oil. That's a pretty dramatic thing, and 200 million tons of CO2 emitted into the atmosphere. Why is that the case? Why is it that programmers can save the world by writing software for cars? This is a picture of a car of a Prius. Of course it's a Prius, because it's in Oakland. Friend of mine has made, and he has put the Robo Car equipment on it, and it's expensive today. And he has allowed this car to drive him from the Fisherman's Wharf in San Francisco over across the Bay Bridge and into Oakland while he's sitting behind the wheel in case it does something weird like try and drive off the bridge. But he doesn't have to actually correct it. This is something that someone has built in their garage and is driven across. So let's imagine what the RoboCar world of the future might be like. You push a button on your cell phone, and within a modestly, much shorter than the time it takes to hail a New York taxi cab, a car comes to you. The car has your name on its little screen in front of it. You get into it and you ride in a pleasant work environment where there's a screen, a computer, a desktop, or whatever. It accelerates actually slowly. Or if there's two people, you're actually sitting facing each other and you can talk to each other, or you can dim the screens and do whatever you want. You arrive actually at the elevator lobby of the building you're going to. Because it's a little electric car that's allowed to drive inside. And this is all done without central control and without any new infrastructure. Now, what's important about this is that if you have that ability, this robotic taxi, it may be a vehicle you own or it may be just something that is a taxi, you can take the right vehicle for the trip. How do we do cars today? Today, everyone buys the car that will meet all their needs. If they go skiing once a year, they buy an SUV. If they move cargo once a month, they buy a pickup truck. All of us have 5-passenger sedans. Well, you're New Yorkers, okay, some of you don't. But everyone in California owns a 5-passenger sedan, which they mostly use on short trips with one person in the car. What if you could call up different cars for different needs? So when you are skiing, an SUV shows up, but when you're just going downtown, something as simple as this little 3-wheeled fiberglass shelled vehicle I show a picture. This is a real vehicle that exists today. It's not robotic, but it's just an example of the efficiency. This ultralight vehicle, what if that showed up? Well, that has amazing energy consequences. You could own a car, but the car could rent itself out and make money for you when you weren't using it. Or you could simply not buy a car. This turns out to be greener not just than the cars we have today, but even transit. This chart is an amazing chart that I worked out after pulling out some numbers from the Department of Energy's study of transportation energy use. It's how much the various modes of transportation in the United States use in terms of how much energy per passenger mile. So 2 people in the car, it's twice as good, but 1 person in the car, it's the energy of the vehicle. Now, you could reverse this and get miles per gallon, but it turns out it's better to think about it as energy per mile. And they do it in the wonderful unit of BTUs per passenger mile. The United States, the only country in the world that uses the British thermal unit. Well, so cars come in, nationally average, over all the car driving in the United States, come in at a number about 3,400 BTUs, and that's the equivalent of about 22 miles per gallon, the average performance for cars. Actually, 36 miles per gallon, because the average car, again, across all driving, has about 1.5 people in it. I don't know what the half person does, and you can't get in the carpool lane with 1.5 people, but somehow that's what's in an average car. But amazingly, look at the numbers, if you can see them, they're a little small on the screen, for a city bus. City bus is more than the average car. Light rail is more than the average car. Heavy rail transit like subways, just slightly less. All right? The San Jose light rail, San Jose is a town in Silicon Valley, 7,000, twice as much energy per person to move people than the average car. Now look at that little tiny green one at the bottom. That's that little electric tricycle I showed you, 300 BTUs per passenger mile. You're also seeing there the current electric cars you can buy today. The Tesla, for example, is in that little green section. The Tango, a car I'll show you. So if you actually were able to move transportation, which I believe robot cars can do, into lightweight electric vehicles, something we already know how to build, doesn't require fancy new batteries, doesn't require any kind of revolution in that area of technology, only in the robotics technology, suddenly people can drive in the right vehicle and they can be 10 times more efficient than transit. Now I knew you'd ask, so I didn't have the numbers on here. The New York subway is just a little better than a car. The Brooklyn subway, believe it or not, is better. The T in Boston is much worse. The light rail in New Jersey is actually one of the best ones. I don't know why this is, but these are the DOE's number. And today's electric numbers come in at those values. So the reason this works is that robots don't care about how convenient it is to refuel. All right? They don't care about waiting. They don't care about, well, they don't actually park. Legally, what a robot would be doing would be standing. It could actually sit in someone's driveway. It could sit in front of a fire hydrant. It could sit in giant lines of valet park, they're not valet park, the valet is built in, but giant lines of tightly packed cars. This actually enables all the alternative energy technologies that people have been dreaming about for transportation for some time. Why? There's a chicken and egg problem for an alternative energy technology, be it electric car charging or hydrogen or any other fuel you're thinking about. Nobody wants to buy the vehicle because there's nowhere to recharge it or refuel it, and nobody wants to put in refueling stations because there's nobody who's got the vehicles. But if the vehicles will go out and worry about that problem for you, they just drop you off at the door of the theater, it goes off and drives some inconvenient but not too far distance to find a place where it can recharge itself. You don't have to worry about it. Suddenly, the technologies we have today, lead-acid batteries, all these simple technologies that have been around for a long time, Suddenly they become marketable. We know how to make electric cars. Robo cars can save the electric car. I mean, who killed the electric car? Okay, fine, there was a movie that talked about that. But I think it was the battery. I know they don't agree necessarily. They think there was an evil conspiracy too. But it was a combination of the battery and an evil conspiracy. Let's put it down to that. People just, they won't tolerate right now. They just won't buy them. I don't know why. It's not always a rational decision, but they won't tolerate the cost of the batteries, the limited range that comes from the batteries, the long recharge times, and the poor availability of a fast recharge. We can make this efficient, short-range electric car, but no one's going to buy it. It's all about what you can market to people. And the robot car can make that happen. The car on the right, by the way, is another single-person electric car you can buy. A friend of mine has one. It's way too expensive because it's made in very small quantities. But it's also very efficient. Not as efficient as that tricycle, but about 3 times more efficient than transit. Now, Moore's Law can finally come to transportation. You've seen the graphs of Moore's Law. But transportation has been the thing that has barely changed. I mean, the great revolutions in transportation have been the 30% increase in engine efficiency we did get in internal combustion engines from the 1970s into about this period, which, by the way, we used to build bigger SUVs. The reason this happens is that computer technology is bought by the most wonderful people in the world, idiots called early adopters. Now, early adopters are people who will buy the hot new cell phone from Apple, and then 6 months later, a new one will come out that also costs a fortune and has an extra feature, and they'll immediately be out and buying that. I'm sure no one in this room did that. That's how they buy technology. They'll waste their money on the coolest new technology to make it happen, and that drives innovation. It drives competing companies that are willing to provide all sorts of great new stuff and sell it to these suckers, and they can then build a market, and it moves on to the next group of people. In the, you see all these business books, they have these lovely charts of who all the people are. But those early adopters are the great people. Transit systems, in particular, are bought by municipal government bureaucrats. Now, municipal government bureaucrats and administrators, they are not early adopters. They buy 19th century technology. If we can revolutionize technology by something that's bought by ordinary people, individuals, early adopters, one at a time, then you get what Moore's Law brings, the ability to have something that's twice as good every year, at least in the software end of it. So some of the steps we're going to take on the way to get there include the existing technologies I told you in the other cars, the cars that are safer, the cars that make driving more convenient. Then something I'm going to call a whistle car. It's a name I've made up, and I'll tell you about it on the next slide. Eventually, we will see something akin to what my friend has built, a car with an autopilot like an airplane, that you can turn it on and drive it, but you still have to monitor it. Finally, the cars will match a test that I've devised for them. It's kind of my Turing test for robot cars. I call it the School of Fish test. How many of you have gone swimming with a school of fish, scuba diving, snorkeling? How many of you have tried to touch the fish? How many of you have succeeded in touching the fish? Okay. Amazingly, the fish can do that. So I believe we could put a test together where there's a track and there's 1,000 robots swarming around the track at high speed, and we give the skeptic the keys to a BMW, and we say, go ahead, drive into them like crazy. And if the robots do their job right, and I believe there are algorithms to make this happen, they won't be able to hit a robot. And then when they're a little more daring, I say, let's go for a walk, all right? And we'll walk among the cars, and they won't do it. So in fact, I have proposed, the X Prize Foundation, which many of you know, is considering doing a prize in robotic cars. The military did these 3 great prizes, remarkable, amazing innovation from tiny little prizes, as far as the military budget is concerned, like $1 million and $2 million prizes. So it's time for another prize. The military has not stepped up, and so the X Prize Foundation is doing this. They're proposing a series of contests which are man versus machine, because that will actually get a lot of excitement. I proposed a version of this which is a safety contest. And so what we get is we get NASCAR drivers on one side, and we get robots on the other side. And then we get, initially, fake pedestrians. And the fake pedestrians are also little robots, but you've seen those robot war shows, the guys with the radio controls, and they can zoom around, and you stick a little dummy of a human being on top of the robot. Okay, and so the fake pedestrian guys, their job will be to veer and jump in front of people and do as much as they can to get hit. And the question is, can the NASCAR drivers hit fewer of them, or can the robots hit fewer of them? I think it'll be a lot of fun. The point is that if we get to the level where the robots can win this contest, where they can do better than the best human drivers at driving safely, then that's the step that might make the public more willing to trust this. The whistle car is an intermediate technology I've been thinking about, which is a car which is, you still drive, but it delivers itself to you, and this enables car sharing. You've got Zipcar here in New York and other car sharing services. The problem is that there isn't one in your house, So you have to go and get it. You can only take it back to where it was. This is a car which doesn't actually go very fast, so it meets the safety requirements. It's not actually rated to carry people, but it just goes down special roads. But what it can do is deliver cars. That's the only thing it does, is deliver cars. It could deliver groceries and stuff too, but this kind of vehicle could happen much sooner and can give us these energy benefits, because that vehicle can also, you could still drive it up to the door of the theater and it could wander off, crawl around somewhere, find a place to recharge itself, find a place to refuel itself. So it doesn't bring us all the safety that we were hoping for, but it doesn't let you work while you're riding or whatever it was you were going to do with the windows tinted. But it does allow you to get the energy benefits, and that's actually for some reason more interesting to people today. So what are the political barriers? Well, for one thing, it's probably not legal right now. You probably still have to have a licensed driver in control of a car. We've been having some arguments about whether the vehicle code actually says this, because you know, they didn't actually think about this when they wrote the vehicle codes. But whether there's a licensed driver in the car may be enough. But you have to make this happen. It has to not be over-regulated. Now, the government will have a role. It is going to do something to certify that these vehicles are safe, that they can meet the safety requirements. They have to do better, in fact, much better than human drivers. I actually, to pose this in a different way, people are very scared for some reason of being killed by robots. And they're going to have all sorts of jokes about this. I've already predicted the jokes. There'll be the blue screen of death. There'll be the computer crash, right? So people don't want to be killed by robots, and so we're actually going to be quite demanding of these vehicles. We're going to demand, in fact, that they probably be 100 times safer than human beings before we're actually very comfortable with putting them on the roads. I feel that's sad, but one way I put this was that if aliens were to come to Earth and say, we have a cure for cancer for you, and we'll save 100,000 people every year with our cure for cancer, but the price is we get 100 of those people who were going to die anyway, and we get to eat them. So would the human race take that deal? And some of you are saying yes. I see some hands going up yes. He's saying yes if I can pick which people get eaten. However, by and large, I think the human race wouldn't, because we are, just for the same reason the FDA exists, where we're very, very concerned about people dying because of what we do or what machines do, and we're much less concerned about people just killing each other randomly on the streets. That's okay. So that's true. That's the way it works. So that's why there will be a lot of effort to regulate this. But the plus side is we might actually get some competition between jurisdictions. We might actually have, you know, one city saying, we're the city of the future. We have the robots. We welcome our new robot overlords. Your city, people are still sitting in traffic, driving to work all the time. So it may be that the first place we'll see this will actually be outside the United States. Some of the countries I've identified have included Singapore, where, you know, they just got a general look and say, hey, that's cool, and suddenly the law changes. China has somewhat the same system. China also has a disturbing reverse ability. They would happily let the aliens eat the people. Because, you know, some of the stories I've heard about Chinese bureaucracy covering, well, I mean, we all saw the earthquake and the schools that were collapsed, and they immediately covered up the people who had been negligent in building the buildings. So they don't have that political barrier. They do, however, have a lot of good technical people. India, of course, also has a horrendous driving problem and a lot of really good technical people. Israel has a horrendous driving problem that's very different from India. In Israel, it's deliberate. And in Japan, of course, what we know is the Japanese, for some reason, love robots. Right? So these are some other countries where, even though this technology is being pioneered in the United States, it may very well show up in other countries first. However, there's some great lobbies here in the United States. Anyone with children who doesn't have to take them to soccer practice anymore will be thrilled at this technology. People who are getting old and who can no longer drive themselves will actually be big fans of this technology. New Yorkers who don't have driver's licenses will be big fans of this technology. Of course, you already have Robo Cars here. You just use Iranian intelligence, I believe, to drive your Robo Cars here. But, and then finally, the drunk. And oddly enough, we'll see the Mothers Against Drunk Driving getting together with Seagrams to lobby for robotic transportation. Seagrams can sell you so you can get pissed drunk, and then the robot will take you home, and the Mothers Against Drunk Driving will be glad that it doesn't hit anyone on the way home, because it's not drunk. Now, I've talked about some wonderful benefits, and I do think those wonderful benefits are, but no technology is perfect. They all have downsides, and even if they don't have downsides, humans find some way to create downsides for them. So for example, it's quite possible we could make a world where nobody walks anymore. That would be okay with me. But it wouldn't actually be. We might actually see, instead of the energy improvements that I've described, people thinking of this as a way to take longer trips. Because it's not, I'll just get in the back of the car, I'll go to sleep, 8 hours later I'll be up in the Finger Lakes, and that'll be cool, and so I'll actually be burning more fuel. I've actually dreamed of something which seems really cool, but it's really energy inefficient, which is a moving house, which is like 10 RVs, which follow you around, and then they dock to each other. And now you've got this house. Well, the problem is, that's not green at all. I don't care if you put a battery in that, that's not green. So, but these are the kind of things, so people do find, just like I told you, how we improve the energy of our cars, and our average gas mileage actually went down because we just used that efficiency to buy bigger SUVs. We got, I'm not going to pretend that computers don't occasionally have flaws. So we are going to worry about computer intrusion, we're going to have to worry about bugs, and we're going to have to worry about privacy and freedom threats, which is actually what I do in a lot of my regular day. I put a picture up there of the movie, the Tom Cruise movie, Minority Report. Did any of you see that film? It had robot cars in them. It had a lot of really cool things in them. And one of the things it had, which I thought was both cool and scary, was that when they wanted to arrest Tom Cruise, they were just able to command his car to take him back to the police station. And he had to have this big scene where he broke out of the car while it was driving, and it was all very dramatic, which is, I think, the reason they did the scene. But for you, the thing to worry about is the idea that, indeed, the police are going to want to control your car. They're going to say, well, terrorists are going to take these cars and use them for whatever terrorist purposes that they have. So they're going to use them as a potential way to control people. And these cars will be taking video of everything everywhere. There's no question, and they'll be recording. In fact, we want them to record it because one of the great things about the recording is we'll be building trillion-mile test suites so that every new piece of software that's developed can immediately be run through data, real-life world data of driving 1 trillion miles, and every possible accident that's ever happened that any other human has had while recording or that any robot has had while recording, and make sure that it would not ever have that accident again. So you can do that to certify the safety of the vehicles with that recording. But that's got some real nasty privacy implications. So there are also basically some barriers. I talked about the barriers from the law. I talked about some of the barriers from fear, but again, they're not going to eat us, but again, the robot's killing us, it's a thing. Liability is an interesting problem in the United States. It's one of the problems that's not true in the other countries. In the US, we have a system where the court system, if it sees a big defendant, will go after it. And in car accidents right now, after a long history, we've worked it so that we only sue the other driver by and large, and the insurance companies fight it out. The civil aviation industry in the United States was almost destroyed when they discovered that any time a plane crashed, you could sue the manufacturer of the plane and find that they were 5% liable for the plane crash because they sold worn-out spark plugs 30 years ago. Literally, this is true. And the aircraft manufacturers were finding it cost them more in insurance to make a plane than it did to, that they could sell the plane for. And so they simply stopped making planes until they were actually able to convince Congress it was so drastic that they should change the liability rules. That may be what's necessary here. I did talk about the terrorists. We are too afraid of terrorists in our society, I believe. But nonetheless, even I get a little spooked at the idea that a robot vehicle could, well, they don't seem to mind killing themselves to do these things, but I'm not sure I want to make it easier to do it without killing yourselves. So we want our robots to be able to take us right to the front doors of buildings, right into the lobbies. I'd love them to be able to take the right to the plane. Imagine landing in the plane, and you just walk down the steps of the plane, and you immediately get in your little robot right on the tarmac, and it zips you home, and your luggage goes home in another robot. That's the way I want to fly. That's how it is. If you're a billionaire, that is how you fly. But I want to do it for less money. There is a small matter of programming. The concept of software recalls is something that scares me. If they find a bug in a Robo Car software, will they say, we'd better shut down all of our cars just because we're afraid of liability? If they do that, the customers aren't going to be very happy that all the cars suddenly say, sorry, I won't drive today. I'm running Windows. So a couple other topics I'll talk about quickly, but I want to get into questions. I've also discovered that the idea of this doesn't have to apply to just moving humans around. It can apply to moving stuff around. And the stuff can be moved around in much simpler little things, little tiny things like you saw moving through the Death Star in Star Wars, the little tiny little robot that scurries around and delivers stuff. You've probably seen these in hospitals. Hospitals have little robots that move around and move the drug tests and the pharmaceuticals and stuff around the hospital. Well, imagine a world where everything you want to order can be at your house in just a few minutes. In fact, I've even considered building a Harry Potter room of requirement out of my old garage, which I won't need anymore when I have a Robo car. And the car will have the code to open my garage, and it'll just bring whatever I need. So if I need a guest room today, a guest room will show up in my garage. If I need a workshop, then a workshop shows up in my garage. If you live in an apartment, that's a little bit harder. I've also been thinking about the consequences of what I call the poor man's teleporter. If a robocar is really that comfortable environment, if you can work on the phone, watch movies, do the internet, all that stuff while you're moving around, it may be that you don't consider distance to exist at all anymore. I mean, yes, it still takes time to get from A to B, but if the time is entirely productive, it may be as though distance doesn't exist. This may have results in the way our cities are designed, how we interact with other people, whether you need to have downtowns, whether concentrations of material that people walk between make sense anymore. I'm not enough of an urban planner. I'm not sure anyone's enough of an urban planner to worry about that. So there's a lot more stuff to write about. I've put it up on the site robocars.net, where there's a bunch of other essays with more depth on these issues, but I would love to take your questions, and thank you for listening. And you were first, were you? All right.
So I live in Panama City, which is now building a metro, and they're going to spend $1 billion or $2 on it, and it seems that it might be really close to the time where instead of really building a metro, we might want to invest that in this kind of technology, or else build a dedicated channel for these robot on-demand cars.
One of the things I pitch is that the great thing about this is the need to not build a dedicated channel, that we've already spent a lot of money building this infrastructure. So a lot of you, how many of you have heard of something called PRT, Personal Rapid Transit? It's only a modest number of you. It's a movement that's been around since the 70s for basically little elevated track robotic cars, but they run on a special track, so they don't need to worry about being able to drive with humans the way the ones I showed you in the videos do. And it never happens, and part of it is because it requires this change of infrastructure. So municipal governments, there aren't early adopters. I really think this wins because it comes from the ground up. It's not designed by the government necessarily. It's done by individuals who walk down to the store and they buy it because they think it's cool. But on the other hand, I agree that if you follow my logic, a transportation planner should say, boy, should I spend $2 billion on this? Probably not. Because frankly, I think, these guys, they did those cars to win a $1 million or $2 million prize. Like these prizes sometimes go, some of them spent more than the prize money in order to get to it. But that's still just a couple $1 million. That's nothing in the budgets of transportation planners or of our car companies. So
if they want to spend $1 billion now, where should we... And they're influenceable.
My sad truth is I don't think you'd ever convince them to do something as radical as this. But that's the way of it.
These sound ideal for the average consumer, but you were talking about the military building them. And the only reason I thought of my question, being a veteran from Iraq, I was just wondering, even if we were to up-armor them and put them into a war zone, would they know if they were to get hit by an ID and shot at? And if so, what would they do? And
well, they wouldn't care, which is the cool
part. Humans, we get a little more perked up and get out of Dodge, but the other question I had is, would it survive an ID hit? Because it's not necessarily the shrapnel and the blast that kills you, it's the shock wave that destroys your vital organs. Would it survive the blast?
So the reason that it was DARPA, the military, the microphone's on? The military agency that sponsored these contests is exactly to meet the need that you're talking about. Their problem was that, they're in Iraq. If they can send materiel through the streets of Iraq without putting a soldier at risk and not having to have that soldier come back in a box, that's bad PR for them when soldiers come back in boxes. That's what they thought would be the really great application. But the truth is, I think their thinking was the fact that, okay, it gets blown up, we lose a somewhat expensive robot, money they don't care about, soldiers' arms and legs they care about, and I think that's the main focus. Eventually armoring them, absolutely. One of the contestants, I didn't really show the video too much, most contestants built really small little cars, they wanted to be nimble. One of these big had this giant, bigger than a Hummer thing, because they knew who the real customer was. And in the contest, it turns out it couldn't actually fit through the gates in the test. Yes.
from your movies, you get the impression that this is a recent thing, but let's mention the pioneer of robot cars, Dick Munz, who already in the 1980s built robot cars going on empty streets, and then in 1995, 15 years before your movies, or 10 years at least, already had a car, a Mercedes, going from Munich all the way to Denmark and back, 1,000 miles, with up to 120 miles per hour, much faster than the robot cars in the desert, and also in traffic, tracking with vision up to 12 other cars, passing them automatically. A safety driver was on board, of course.
Yeah, so that was Mercedes and Uni BMW together. No, it wasn't BMW, it was another company. Yeah. But anyway, there's an important caveat on that story, which is that they had human beings in the car.
And finish this one thing, because, you know, I'm from Bavaria, where the first robot cars were built, and now I'm greatly worried that you say the Americans pioneered that technology, and now I'm worried. And now I'm afraid that next time you're going to say the Americans also pioneered lederhosen and sauerkraut.
Frankly, you should be thankful if I say Americans pioneered lederhosen, but you're absolutely right that there's been some great work there and in a couple of other countries. The technology done in the DARPA Challenges is quite a level above the technology, though, that was done in the 90s in the German tests. And I will say that while those were very impressive results, they had humans behind the wheel, and the computer drove the car 93% of the time. 7%.
No GPS.
Yeah, well, 7% of the time, however, a human did have to correct what they did. In the DARPA Grand Challenge, the humans were not allowed to send any data to the cars whatsoever. If the car made a mistake, it was just out of the race.
But going 60 miles on the Autobahn.
Yes.
Without any human intervention.
If you drive only 60 miles an hour on the Autobahn, you're going to get hit.
Yeah, I'm in the automotive industry. You spoke about terrorists, but really you would reduce the amount of drug smuggling and things like that because these cars would be intelligent with cameras, right? You would notice a guy with a big bag of cocaine putting it on the car, and it would be uploaded, I'm assuming, to a satellite link, right? And also...
Oh, God, I hope not.
What about the negative effect on the collision industry and the insurance industry?
Yeah, fuck them. Actually, there's one positive that one of my readers pointed out, and I thought it was fascinating, that today we live in a world where everyone violates the traffic code 100 times a day. So the police can always stop you. They can just say, you came to a rolling stop at that stop sign. They always have a reason to stop you. They won't be able to do that in the robo-car. So whatever negative things it's doing, it will eliminate the police ability to claim you're always violating the traffic code, unless you've got a buggy robo-car. Which side was next? You were.
Okay, this seems to me sort of like antibiotics, how like you introduced it and all of a sudden there's super organisms, you know, but this is going to be with humans in the reverse in terms of like sensory processing. And isn't there an advantage to like being aware of what's around you? And because not everyone's going to have these, you know, like aren't we like changing the human sensory processes and like we're not paying attention, we're stopping like to pay attention to a lot of things that are around us, and what do you say about that?
Well, I mean, yeah, when I drive in a limo or car service, for example, I'm the same thing. I'm reading the newspaper. I'm not paying attention to what's going on. I don't think that's a bug. I think it's a feature.
Right, but now it's going to happen to a lot of people. And a lot of people are not going to be paying attention. And then that breeds more to like people being taken advantage of, and isn't it going to be like changing the whole like biology of how we think and how we see, and eventually?
So, I mean, I'm surprised to hear that in this town, because this is the one town in the world where it's much less common for everybody to drive everywhere they go. I mean, a lot of people do just ride cabs here and don't even own vehicles, and I've never heard that as a negative about New York. Okay, not never. I have to say I disagree with the point.
Oh, it wasn't a point, it was a question. Just.
Oh. Well, somehow I disagree with the question, but thank you for asking a question. Usually I get long polemics that are disguised as questions. So, go ahead, give us your long polemic disguised as a question.
What a setup. So, I love the presentation. There is a potential downside I'm wondering if you've considered, and you didn't list it on your slides, and it has to do with our ability to very quickly assume new technologies are always present and uneven distribution of technology. So when you were talking about the challenge, the School of Fish challenge,
and having a person walk out in the road. I could absolutely see us having cars that could handle, robot cars that could handle that challenge out on a track. So imagine a place like Singapore says, you know what, we're going to go to all robo cars. So now kids growing up in Singapore say, cars never hit me. I can do anything in front of a car, and then they go to someplace else. What happens then?
Well, yeah, that's a good one, because I do talk about the first part. I didn't think about the fact that they move somewhere else, that yes, it's a danger if parents think they can no longer worry about their child crawling into the street, because, and the other thing, though, that I do write about, by the way, which is much scarier, is the kids will, once they find the cars won't hit them, they will, of course, go dancing in the streets. And this will be very annoying to the people who are driving along and their cars suddenly go, and in some cases deploy the airbag. And for adults, you'll ticket the person who jumped in front of you and forced your car to brake suddenly and deploy the airbag or whatever it had to do. So you'll have some way of punishing that person, which you don't have with children. And it is one, you're absolutely right. It is one of the issues. People will adapt the technology in exactly the way you describe. I don't think it's enough to abandon the path to the technology, but it is definitely going to be one of the things we worry about. Parents probably will have to teach their children that, you know, the big machines are not as safe as they look. And whether that'll, what parents tell children is usually irrelevant to what children end up believing. So
maybe there's a role for sociologists and human factors people to be able to designate, to make these cars look so different and so unique that you always know what one of them is like. You can always tell that it's a different kind of car.
Actually, you would have to...
Well, actually, a lot of people lined up.
You could just have a very quick solution would be a device that would broadcast to...
My other quick answer is we would breed that out of the gene pool fairly quickly. Yes.
Okay, you were talking about this mainly in terms of the individual robot cars being totally autonomous, each one sort of pretty much behaving as though it's the only robot car. And
the first one you sell has to do that, so yes. There's no question that you have to start that way.
Yeah, so, but I'm wondering if, as this becomes more ubiquitous, as I expect and hope it will, if there will be any use or any room for sort of not centralized, but sort of peer-to-peer coordination between nearby robocars.
Skynet, for example. Yeah, no, absolutely.
Not quite, but...
No, you're absolutely correct. I deliberately downplay that because I believe that to get started, you know, the first car obviously can't talk to anyone. It's very important that they work independently and that they not require any central infrastructure or control. However, yes, of course, just as human beings make eye contact with each other, signal to each other with blinking lights, the robots will communicate with each other to where it's beneficial. In order to do that school of fish test and pack the cars really tightly, what the robots will do, for example, is they'll talk to their neighbors and say, listen, if I had to suddenly veer to the right, could you veer to the right into that empty space next to you so that I can be sure I can always get out of the way if something jumps in front of me? And the other car will agree, and it'll have a certificate to say, okay, I trust the manufacturer of that car to do what I ask it to do. So they will start doing that. Eventually they'll start drafting each other for greater efficiency. You get about a 40% increase, 50% increase in fuel efficiency if cars can draft each other in convoys. I don't advocate that for the beginning because, again, the problems that show up in the beginning, if you ruin a convoy, you could hurt a lot of people as opposed to just one person. Am I getting the hook? Okay, assume we're getting the hook. Yes, that will happen, but I actually think it's not the thing to talk about first. But yeah, on the website you'll see some writing about that. So we get one more.
I'm in the insurance industry. Don't worry, we'll make it up on the product liability premiums. Second point is what will be the revenue source for small towns about the cops? Yep. Third question, a serious one, is there anyone working on just a robot that'll pass the driver's test? Because, you know, that's a key part of the politics of selling it. And you'll say, well, but that doesn't prove he can drive. Well, yeah, the driver's test doesn't prove people can drive.
Well, that's an interesting thing. I don't think anyone really looks at that problem because I don't think anyone seriously thinks that's how they'll get licensed. I mean,
it's a start.
Yeah. My belief, and I think most people's belief is, you know, there will be a safety certification program that is pretty much independent that says whether this vehicle is rated to carry people or rated to travel on roads with people. Small towns will find some way to make money. Trust me, as long as you've got guns, you can make money. Well, thank you very much, everybody. I'm between you and lunch.
It's an excellent presentation. I'll let you give the lab mic.
All right, guys, now we have lunch. We'll reconvene at 1:15.